that's generally in the right area. Okay, cool. Let me figure out why camera 2 went down. I'm going to grab some pizza because I'm hungry before we begin.
I don't think they gave.
Well, there's a lot of napkins inside the Subway one, so if anything, you could just grab the napkins out of there and use them to hold the pizza, or eat the sandwiches and the pizza at the same time. Because, you know, food is great.
Normal people stuff. I'm just gonna grab this bed. Throw it down the ground.
Hello.
Oh, somebody made an entire full-on armor of Sauron's armor from Lord of the Rings in like their basement.
So light goes.
They fully sniffed it. I was like, yeah.
Hey, welcome back. I can do this. It's not Ariel. It's I'm sorry. What was your name again?
Sarah.
Sarah. Wow, that was really off. I feel sad because like I every semester I try to dedicate myself to learning everyone's names, and I just haven't gotten around to doing that this semester. But usually by the end of the semester I get it done. So, where in the world is Michael?
Where is everyone?
It's project week. It's the week of presentations. Everyone's practicing or working on their very late presentation for this.
See, that's the great thing is that my teachers are all sick, so they all push back their
The presentation dates. Alright, I don't want my front camera. I want the camera that's not showing up. Alright, let's just go into studio mode. I guess I'm supposed to hold an election right now, but like frankly, I don't want people here.
Nobody's here today.
It seems kind of wrong to hold the election. Especially since like 2 of the people who proposed ideas outside of you weren't here either. And that being Drew and other people. I wasn't here, I was getting food. But oh my god! That's such a big slice of pizza!
They're all like that.
They're all at home. Wait, hold it up in step 2
This
steps
is
to the
actually
right.
2 slices, but
Okay,
they're
well,
all-
no, still hold it up in step 2 steps this way. Oh my god, it's so big. It's the
the
size
cheese
of,
one's even bigger.
it's the size of your head. Alright. Perfect. Camera 2 works now. Alright, well, if that's the case, I don't think anyone was here last week, right? All of you guys were absent last week?
Yeah.
Alright, cool.
I was here.
Oh, you were here? Well, you're just going to get the same lecture twice, but with more attitude.
I'm just hoping this week's a little bit happier.
Yeah. This week, I'm probably, I'm going to do the same thing you did, grab 2 slices and use those one. I'm going to basically give you guys a conceptual overview of how machines see and identify objects. After I eat this pizza, we're going to have it a little bit conversational style because I didn't want to set up my laptop until Michael got here, and Michael's not here, so I guess I'll do that in the meantime. But
My brain's getting sick.
I don't know.
Oh, there's a language fair going on.
A language fair? What's that?
In the quad, there's you can talk to people.
Oh, in different languages?
Yeah, but I think it ended.
So there was like a ton of trash cans out this morning. I was like, what is this for? Like, is there going to be like a huge event or something? I guess that
It
was.
was a small little event that you could like talk to people. I saw it while I was walking up, so.
No. Anyway, how's your guys' weeks gone?
Oh, better than last week.
You got it pretty rough.
yesterday we were on the phone to my relatives in Germany for 2 hours. My mom had like a full-on breakdown, and I forgot to take a quiz, and so now I have to email my teacher going, "Yo, can you open up the quiz again because I had to deal with stuff." Yeah. We still don't know about funeral arrangements, but yay.
It's definitely not an easy topic.
It's not been a happy semester.
No, it has not been for you. Give me a second.
But
Outside of that,
my dog had hiccups this morning. I was very confused about them. So far, my dogs have been like the only thing that's been like keeping my head above water.
dogs are good at doing that.
Oh, don't jinx it. What about his hiccups?
The hiccups are gonna get worse.
I
No.
mean, it's the stupid stuff that they do. with it.
Michael! Hello! Can we use your computer today?
Sure.
You doing alright? How you doing?
I'm hanging in there. But, staying busy.
You gonna be alright?
I suppose. So you guys have a...
In that case, I'm gonna shut this down. What'd you say?
This is it?
It's a light day. We've had a decrease in the few weeks.
We ordered a lot of food.
Oh, Victoria usually brings some food with her. And we graciously accept it.
I'm one of those people that like to feed people. So
I do.
I don't eat myself that much.
I don't agree with the second statement, but the first statement I do.
Or mayo.
Hello! Speaking of other languages.
So,
Out of curiosity, do you have any interest in race cars?
I like Formula 1, but that's about it.
Actually, that is exactly what we needed help with.
Why? What happened?
the Las Vegas?
Oh, did that happen yet?
No, but
Okay.
I feel like there's gonna be a full-on riot because of like
It's going horribly.
it's so bad.
So you know how the next Formula One race is going to be in Las Vegas, right? So they're tearing up the street. They're taking down all the trees. They're like removing historical guard posts. They're like destroying everything.
And they're upping the prices
Yeah.
on all the
Oh.
people living around
Yeah,
there.
and they're upping the prices. They're blocking off all the windows. Everyone
Yeah,
who
I heard
lives there.
that, like a
Yeah.
year ago, they were already speaking about that.
Yeah, everyone is like pissed over there. But like
I'm surprised.
F1 being F1.
Also, the circuit is shit.
Oh,
Yeah.
From the racing standpoint, the circuit is gonna be fucking more.
Yeah, no, it's horrible. Like they're destroying the streets. Like it's just turn after turn after turn inside, King City. Like it's not like it's Madrid or anything, or not Madrid. It's not like Morocco or anything where it's like a beautiful seaside. But this is going to be such a horrible race.
I'm like,
Are they
they
going to,
could
like,
have
a
just made a
residential neighborhood?
stadium.
No.
They could have just made a new stadium or something like that.
Yeah.
But no, they have to
Well,
do it.
it's
yeah.
F1. F1 traditionally goes through a city.
Yeah.
No, so they're going through. You know how
But
in Las
nobody
Vegas, there's
wants
just that
Formula
one casino strip?
Nobody that
Yeah,
lives
that's it.
in
It's going right
in
down
Las
there.
Vegas
Yeah, no.
wants them there.
No one
because
wants-
nobody watches Formula One really.
there. No one watches Formula One
there.
there. In Europe, a lot of people
I was gonna
watch.
say in the
We're fucking
U.S.
up Formula 1.
In the U.S.,
No,
like
but they
nobody.
are ready through races. Like they are trying to reach that market, and this is like.
This is like the worst way possible to do that. All you're doing is alienating
Yeah.
Yeah.
everybody.
I also hate Formula 1 in America. Like, don't look at me. It's
No one loves the organization, but it's really fun engineering looking at it.
Another thing. Do you know if there's somebody that wants to compete in the business analytics competition?
Oh, yeah, there was actually a few. Were you the one asking about it?
Yeah.
Okay. Michael said I think he was interested, but I think he had to drop out. First person that asked him. I am too. But anyways, our Formula One team here on campus, they're having control gate issues, and I was thinking, oh wait, the control engineer would probably be perfect for that. So
I am in the Discord, but don't pay a lot of attention. What's happening?
I don't know, something about they're having logic issues or something like that. I mean, if you want, their building is the one right next to us. So if you want to swing by there and say, hey, I'm a circuit or sorry, what exactly?
Telecommunications, right?
Yeah, I mean, you might as well see.
I may go see, take a look.
Yeah. Honestly, when you first told me that, I was thinking, I don't know why, but I was thinking a hydraulics engineer.
Nope.
And so like when you said like communications, like wire or fiber and copper communication, I'm like, oh wait, hold on, I was completely wrong. Either way. Did you put a schedule today in the Discord? Or not the Discord, the Drive?
Alright, God. Do I have your phone number
Don't
so I
think
can
so.
organize the carpool?
Oh, is he coming with us?
I don't think so. No.
Oh, okay, cool.
It's gonna be you, Alejandro, me, my friend AJ, my sister.
When is it?
It's the 25th.
Next Saturday.
Not the.
Or the Saturday after next Saturday.
The Saturday after next.
All right, so and whatever. We got like another minute. Oh, I finished my second robot in robotics. It is. I should have brought it with me. Building robots is a real hassle.
Oh,
But
yeah.
like finally making them and moving them around, it's so relieving when you finish your first robot and it works and everything moves properly. Once I finished my first robot,
Talk to my sister about robotics because that's like.
that's her jig. No, so the first one is like this little robot that has a claw at the end of it, or that can like move around in three-dimensional space. It's a robot, but regardless. And I was going around and nipping at people's Achilles's in the engineering hall, and some ME students came in and like, "What are you doing over here, man?" Like, "Oh, I'm just making a robot cause mayhem." It doesn't hurt. The clamping force is on your own ability to clamp is probably more force than my robot could. It could barely pick up a pair of glasses, but like. It was still fun to just have it go around the engineering hall causing chaos.
My sister made a robotic snake, and it like articulates and has the different like winding patterns of different species of snake. And she would freak out her friends who are scared of snakes.
How big was it?
Oh, well, her first one was like that big, and then I think her next one was actually pretty like
It's a
sizable.
pretty complicated. Well, I mean, it's already pretty complicated.
That was her
circuitry.
senior project, so she did it on her
Really?
own.
That's awesome.
She 3D printed the pieces, and then she was so proud of her wire management in it.
Mm-hmm.
Like you could barely see any of the works.
Can you plug in this one?
Yeah.
And all the colors and everything.
That's impressive. Like most of my stuff is from GitHub, but I've gone through and modified it a bit to make the robot faster and whatnot.
Yeah.
But doing it from scratch is really
What's
impressive.
the drone going? Like,
So we're waiting for, Hashem finally gave me a more detailed information about it. Effectively, what Hashem wanted to do, or the model that Hashem chose, requires us to have the camera beforehand and then train the model using the camera.
oh, that's it?
Apparently, which we've had the camera for weeks, but the person who is holding the camera, it's kind of hard to get a hold of, and I'm going to talk to him this week.
Who's working in the project?
So currently, it's only Zach and Hashem that are actively working on it. Hashem wants to build and finish the drone before bringing everyone else on. Not really my decision. If it was up to me, I'd have people working on other stuff before that. But I'm not in control of that. So either way, I'm going to try and get that camera to Hashem as fast as possible so that we can get started on everything else. And ooh, what demo you got there?
We have a total
Backwards.
of how many people are here? 8?
So we're gonna
Yeah.
do some tag analysis with that, or
Yeah.
It's like in the email and the event. It's
oh yeah, I should probably check that out.
like pre-processing and tokenizing. I was going to try and run it through the glove model, but that didn't work for a couple of reasons. Really, it was just taking too long. And then, so I just ended up going with something a little simpler, like k-means clustering.
All right.
But
Want to begin?
yeah, I suppose so.
Welcome, everyone.
Yeah, so so thanks for your patience, everyone, especially in regards to the expo thing. Just had some stuff come up, and it's just taken a lot of time and really pushed a lot of things back for me. So really at this point, just trying to catch up on everything. Long story short. So in any case, it looks like doesn't look like we have too many people that actually showed up for the actual final decision on the expo thing, but that's fine. That just means that we'll make that decision now in any case. And I think it was already kind of trending towards the auto scheduler thing. So I think we'll just go with that unless anyone has any overt objections. And yeah. Oh, also next week, I don't know if y'all knew, but there's going to be like an entrepreneurial week in the Carlson Center, and they are going to have some tech startups talking in there. It does look kind of interesting. There is a calendar you can check to see what events are when. Would anybody be particularly interested in that sort of thing? I can follow up with more details later. But if you're in the Hive Discord, or even if you just go over there and ask about it, I'm sure you'll be able to get an answer. But
And for reference, the Hive Discord is the Carlson Center's Discord.
yeah, the Hive, the Carlson Center is like an entity unto itself, and then the Hive is like a club that's run out by the students in tandem with the faculty in the Carlson Center. And so this is an event through the Carlson Center, and the Hive will do their own things. Really, actually, this semester they've mostly been doing like content creator workshops.
It's all new leadership this semester, right?
Yeah, pretty much. I mean, there's a couple people, but yeah, most of the, I would say the most active people, graduated out. But anyway, it's a cool place though. It's very nice. In fact, I think we might be trying to do something there next semester, but more details on that to follow. What was the other thing? Oh yeah, there is like a business analysis hackathon thing that's going on this week that ends Friday. Someone mentioned they were interested in the Discord, and I progressively. Was that? Oh yeah, my bad. It's one of those things. If we want to like open up the space to try, I didn't get any other feedback. I didn't really ring all the bells I could, I suppose. But if you want to give it a shot, and if you run into something and want to shoot me a question, feel free. Though I don't, at this point, I don't think I'll be able to really properly dedicate time to sit down and try and problem solve all the way through it.
You should try the MIS club. There's probably going to be a few more people there who are going to try to do it.
Is there a club for MIS?
Yeah, for business information.
Management information systems.
Yeah, business information systems.
Yeah,
we usually, whenever we do data analytics style events like that, we usually partner up together with them. So.
But yeah, just figured I'd.
I'll send you their Discord link.
Figured I'd address that. Is there anything else? Anybody else thinking of anything that I missed?
I think
No?
we hit up everything.
All right. So today, I was going to look to I think Drew actually was the guy who suggested that we do more actual tech demos in the sense of demonstration of like I did conceptual stuff early in the semester, and I was trying to speak to a broader audience, but so, and this is kind of, I guess, my first jab at pretty much what we did a lot of last semester, which was had a lot of outside of the speakers. Travis would just share a whole bunch of stuff like he did in when he came and spoke to us. Imagine that, but more or less every other week. You know, it was really cool. I learned a lot that way. So it was a great suggestion, and so. This is something I kind of threw together, so this is, it was originally going to be kind of a combination of something I tried to do at DataFest and also some assignments from Stat 129. So if you're interested in upper division statistics, they have a lot of great classes for machine learning and stuff. It really is more... I would say like Stat 128 and 129, they're almost taught like CS classes in a way, at least when Fitz was teaching them. But you still have to be able to kind of understand to some degree, obviously, the algorithm you're working with. But yeah, so if you're interested in that sort of thing, if you're interested in data visualization and analysis, definitely great classes, like especially the linear regression class. It's 128. I think that was 196L is the
math 196L.
Yeah, the stats one. That class was really actually. I think from that class, I could have gone into an analysis job, at least to some degree. It really teaches you a lot of stuff. Anyway, enough. Shilling for the math department. But are you guys able to see this okay? I am able. Yeah. Okay, there we go. I can zoom, right?
The power of a touchpad.
Yeah. So, yeah, this is work in progress overall. But let's just start with Python, because for people that are new to programming, learning programming, it's like one of those things where it's very easy to get into, but it has a really high skill cap. You know, you can do a lot with Python. And if anybody's used like R or anything, or is familiar at all with R, you're able to accomplish a lot of the same things, but you just have to become familiar with the libraries. And that's just a lot of CS, is knowing what to know, right? So I'm going to focus on the sklearn library. Let me see if I can actually pull it up. Yeah. And so this is a particular, but the whole point of what I want to accomplish today is just kind of to get the names out there and kind of show you even just how to get started, even, because this is really all anything is you just got to go try something. That's how you learn. At least that's how I learned. So just trying something, see how it works. You only really, I think, honestly, figure something out once you're able to get it all together to work. But in any case, it's really interesting stuff. You know, it has all the key features. You know, you have the classification, regression, clustering, dimension reduction is huge, really important stuff, and obviously the pre-processing and all that fun stuff.
What does dimension reduction do?
It depends, but like in the most general sense, a dimension reduction is like if you have, it's like in the simplest terms, it doesn't make as much sense when you're thinking about it in like vector space or like with like like in a matrix or like in a probability matrix and all that, it's not as intuitive, but you can think of it much like taking a sphere to a circle. The idea is you're just taking a representation of points, a set of information you've given kind of dimensional representation to, and you reduce it with, ideally you're preserving that information. So that's a whole thing unto itself. I find it very interesting, but I could spend a long time talking about it. And honestly, I don't think I could teach too much about it. Just that, especially when you're working with, like with Glove, it works. You know what? We'll get to that. I'm getting ahead of myself. But anyway, so yeah. So these here are the main libraries we're working with. Is everyone? Can you see that? Are we all familiar with this? Does anyone need to? I think there's only one that I'm really not super familiar with here.
Let's go from the point that no one knows any of this stuff. So, scikit-learn, what is that? Let's start with there.
Yeah, well, you mean sklearn?
Yeah.
Yeah, that's all this stuff here. So that's this library that we're looking at, and particularly the feature that we're going to be looking at is its ability to create sparse matrices. So, but sklearn, matplotlib, like that's going to be your graphics library, how you're going to make sense of all your output, generally speaking. NumPy is how you get like arrays and all that fun stuff back into Python. You can do some really cool stuff with it, and it with even its kind of like simplest of features. Datasets, I just kind of had to pull that one to get it to work, and then Pandas is like a whole framework it's like a whole library for data frames. And data frames are, again, a whole kind of feature unto themselves. It's entirely what R is based around, this idea of data frames. But, yeah.
What exactly is a data frame?
You can think of it just like a table, I suppose, like, rows, columns, much like, a two-dimensional like a two-dimensional, what do you call it, array. Anyway, so, yeah, so let's talk about Hugging Face. This is kind of the, I already opened it. So this is the data set I decided to just pull from. And Hugging Face is a great sort of, it's almost like the GitHub. I think that's the best analogy, but it's another one of those things where it's just find something on here and try it out. It's got, here at the top, the models, the data sets, and then all that other stuff. But here you can see, you can even then get into different kinds of models, right? Natural language processing, computer vision, and then it's the same for data sets. And so what this is really for, though, this is mostly for training, and what we're going to be doing is something a lot simpler. This is like machine learning, this is like for AI. But with that said, this here, I just kind of pull this data set here, particularly, did I not link to it? No, I did. Yeah, so this one here, this AXG subset split test of superglue. And superglue is just like, I think, a set for context. So it has a bunch of phrases here you can see, like premise, hypothesis, right? And then the idea is you're supposed to like refine it. But the taxpayer met with the accountant to get help filing his taxes, and the accountant sought help filing his taxes. So on and so forth. You get the idea. But it's just a good place to pull a whole bunch of words from, and that's all I needed. And then I cut down the examples even more. And so this small data set is what we're working with. I think it's 132 rows, but we can actually, and Google Colab is also a great thing because it's all on the cloud. It's like a Jupyter notebook, if any of you have worked with that. It's very much the same thing, except you just have, you have these remote resources. If it will show them to me. I thought, oh, it's not connected, that's why. Yeah, there we go. And we've got our data set, and then the first thing I did then was, this library data set pulls it into a data frame that is very similar to Pandas. And so just, again, quickly trying to get this thing to work. Pandas is kind of the next closest thing. It makes it easy to just move it over into a Pandas data set, and then we give it some features and all that. But most of the time, unless you have like a specific most of the time you want to try and work in like a list or a dictionary. Honestly, a dictionary will be how you're doing a lot of what you're doing in Python. In fact, I even tried to write like a CSV, like a custom CSV to dictionary thing right there, using regular expressions. But this is a whole other can of worms, really. But it's just really valuable, both the lists and the dictionaries. And they both have their pros and cons. And that's something you can really get into the weeds on your own time. I want to get to the cool stuff. I'm just kind of trying to give you guys some context here for what's going on. So it's not just a block of words you got to squint at. So then, yeah, you know what? Oh, here we go. Yeah, so you see here, I've got 107 gigabytes on the disk, and then it gives me RAM, and then I don't know if it tells me exactly what processor I have, but and you can also, it has TPUs, which is like their TensorFlow processor. It has a GPU you can use, and then you can pay for some better stuff. And then let's just go ahead and just got to run these things here. Make sure all that's installed. And all right, and now let's look at the data frame we've got right here. So you can see here that we have what we were looking at over here, right? Taxpayer met with the accountant, got help filing his taxes, blah 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 blah. Yep.
All the same data.
Yeah, and so we have now this data frame with columns premise, hypothesis, IDX label, right? Now what? So we need it in a list because what we're ultimately doing is k-means clustering. I think you guys might have heard that previously before in this room. Is anyone familiar with k-means clustering? No? Well, that's, you can do a whole bunch of stuff. It's kind of a very, I don't want to say it's simple. It's definitely simple to use. I don't know if conceptually it's simple, but it's great for like identifying patterns and then grouping those sort of
similarities together.
Yeah, like the set that you give it, it'll find the patterns in it, and there's all kinds of applications in that. So it's like, one example I came up with was, hypothetically, you could use it even for like bot identification. You know, if a bot just says a lot of the same thing or follows a very simple pattern over and over and over, it could probably, if you gave it two cluster groups, group one into people and then group the other into like bots or whatever, right? But that's kind of ethereal. We'll be able to see what I mean in a second here. In any case, so we see here, you all believe me, there's this data frame. You can see the column names here. You can see even like the column data types and all that fun stuff. And then we got to turn this into a list. And then what I'm doing here is I'm turning it into the sparse doc matrix. So how many of y'all have worked with like matrices before? Okay, yeah. So you've got some idea of at least the look of it. So there's, yeah.
That includes the matrix that was featured in the movie of the same name?
Different kind of matrix. We're talking about a data set, so a 2x2 array list. So basically, like think of when you play tic-tac-toe. You have a 3x3 grid.
Yeah.
Your X's and O's are your data.
Gotcha.
That's basically what a matrix is.
Well, shouldn't they use that? Shouldn't they use that in the movie Matrix because it's called the Matrix for a reason?
I honestly have only seen the second one, which I know is kind of criminal, but you can mug me later.
Yeah. Well.
In any case, well, just in regards to this, the whole point is to get to a sparse matrix. Now, do you guys know the difference between sparse and dense matrices? No? Okay. Well, that's why I've got this here, actually, then. So we can see here that this is the actual memory, I believe, used by the sparse matrix. And then this is the calculated memory that would be used by the same dense matrix. And so what they really are is it's a word matrix. So you've got each row is a document, and in this case, I'd imagine it's like a sentence is considered a document. So you've got your first row as a sentence, and then each column is, I believe, a word. And so per count of word, you're going to get that represented in the matrix. So if you have two instances of the in a sentence, like the taxpayer met with the accountant, you would have two under the column the of the document 0. And so the thing is, though, is that it will make a column per word, and if we used a dense matrix, it would represent every empty space with a 0. But to represent all that space as null, as nothing, takes up space. And so here, it's not that big. It's hardly even a megabyte. But imagine, though, you're working with a set that is huge, terabytes of information, to try and do a matrix operation in any sort of way. It's you would need a really powerful computer. And so working in a dense matrix just dramatically reduces your the demand for resources while still being able to accomplish everything. You're just not representing the zeros. They're just kind of null, or not even that, I think. Kind of just undefined. So yeah, that's why we use a sparse matrix here. Generally, when we want to prepare for a corpus of words, a bag of words, just makes life easier.
So the difference between a sparse matrix and a dense matrix is the amount of data that the matrix is going to end up using after it's been filled.
Yeah, essentially. I mean, it's basically, in a sentence, it's like the sparse matrix does not represent lack of words, where the dense matrix does with zeros.
Okay. Cool.
Yeah. So let's see. And then this one here, this is like what are our top 10 words? So that's like, what are we doing here? What is our purpose here? We're trying to even just identify patterns in words. Like, that is a huge part of natural language processing, is making sense of words beyond just, the meaning.
So it's like a word cloud type of deal?
I think that's like a visualization technique.
Mm-hmm.
This is just showing that, like even when we just look at the most frequent words by their count, we can kind of start to get some idea of what's going on here. Because if you had a whole set of words, of sentences, you could parse through stuff as you do to gain context, but you will inevitably, when you go into data science, have to process loads and loads and loads. So you can't read through all that. You gotta use these sorts of abstractions, and we can see patient, child, customer, told, wanted, homeowner, student. So we have some nouns and we have some verbs, and I think, like if you had to ascribe an idea to this set here, what might be just one sort of generalization we could make about what's going on here?
We omitted small words like the, of, and.
Yes, actually, that's
An astute observation.
that's a good point, and something I forgot to point out. So when I initialized even, where did I do that? There's this other concept called stop words. So there are certain words that we use that are useful to convey meaning, but when we're trying to actually, when we get to the brass tacks of things, you can't really gain meaning from a certain amount of thes or a's, or, you know what I mean, like the pronouns and the priest like nouns and
The filler words.
yeah, I'm not a grammar person,
No.
but the filler words, exactly. Actually, pronouns would give context now that I think about it, but
I think they're called articles.
yeah, okay, yeah, I think but you get what I mean, the simple 3-letter single letter type, and so it's honestly best, generally speaking, for you to look at your set and create a custom set of words to remove, because there are built sets out there. In fact, this one does come with one. You can even see here stop words, and it defaults to none, right? But when we look here, that there is a set of stop words that they use, and that's going to be stuff like the,
Two.
so right, exactly. So, something that's not going to give us a great deal of meaning, that's easy to remove. Even if you removed it from a sentence, you might still be able to understand what's being said. So that is something I did already. Forgot to mention that. And that is part of the count vectorizer, yeah. And that again, all it's doing is making just the counted word matrix. And so, where did I do that? I guess,
Scroll down.
yeah, maybe I transform it there. Oh, there it is, duh. Yeah, right here, stop words. So that immediately takes all those out. It's just easy, And then the fit transform process here. So this matrix isn't actually a set of words. So what this model has done is it's kind of measured. It's not a good explanation, but the best way I can put it, it's taking sort of the, you know what, actually I have a good thing here that kind of talks a bit about it. So the fit transform, and fit transform is a combination of operations. And when you're testing and training, you want to kind of do one or the other. Generally speaking, you're not doing both, because what this count vectorizer is doing is kind of creating a model representation of the words. And so it's kind of like measuring the space between them and creating a standardization. This one really gets into the mathematical representation of it and stuff. So if you were testing your set, you wouldn't want to refit the model you made, because then it would just basically have then seen your test set, and thus no longer as a test set. You've taught your set or your model on your test set, and that gets more into like training and testing and stuff. But did that make sense? Where you want to have your trained model on a set of information, and then you don't want to continually train it. Once you think it's adequately trained, you're going to want to have your test set to see if your training is correct. And if you use your test set to train it, you can no longer test on that set because it's now retrained to that data. Does that kind of make more sense?
Yeah.
Okay. So that's kind of what's happening here, is we have this matrix that is ultimately a representation in that way, a model of the words that is being represented in this kind of vector space. That is the fit transform process. So counter vector looked at the words we gave it, mapped all the words in the vocabulary, and then kind of measured the values, the difference, and all that kind of stuff. I'm forgetting all my vocab words right now. I just had 2 exams, so I'm kind of, but I think you get what I mean. So let's see. Yep. Okay, so, and then, yep. This is what I was trying to do ultimately, and it was just, the problem I ran into in this is that the glove model has, this one in particular, you can even see here in the name, represents its vocabulary, I think, in 50 dimensions. And so ultimately its purpose is to graph word vectors, I believe. And you need to do that in a 2-dimensional space. And so there's definitely a way to turn that 50-dimension representation into a 2-dimension space, but that was going down a rabbit hole, and maybe next time. Maybe this is something in the future to get working. I definitely intend to, but learning despite school kind of thing, But yeah, definitely an interesting thing to run into. The other thing is that actually in this case we don't want to be using. We can't really use the sparse matrix to test the glove model, I guess you could say, because it's not an actual document. It's just a representation of the words, not the words themselves. So if Glove were to try and process it, it's not even like really a referenceable object outside of its library key terms, I suppose. You can't, nowhere in the data does it actually store the words. So yeah, so that didn't really work, and so we can just kind of fly by this. And now we can actually look at this stuff here. So the TF-ID vectorizer is sort of, it's another thing out of this the sklearn, and it's very much the same idea, where you're taking these words and you're representing them in this matrix via the measurements that this library has taken of the words you've given it. However, I forget actual what the word or the name actually stands for, but it just weights the words based on uniqueness, essentially. And so why might you want to do that? Instead of, so there's two ideas we're talking about here. You have just this count vectorizer where you're simply counting the words, right? And then you have the TF-ID vectorizer, which is really, it's still kind of counting, it's taking stock of the vocabulary, but it's weighting them. I think it's on a ratio of like 0 to 1. Don't quote me on that. It's been a while, honestly, since I've really messed with a lot of this stuff, but in any case, why might we want to weight the words a little differently other than just their count number?
Important. Oh, sorry.
For context, if we're looking at something that has more emphasis as to what is being looked for.
Yeah, yeah. Drew, did you want to add something?
There's going to be a different way based on context. It's also going to be, recently in my class I went over the idea of decision trees and entropy and the amount of data that you gain from a certain data point within a set.
Yep.
That but in the context of words.
Yeah. I mean,
it's give you more information about what words are next, that kind of thing. What associations can happen from there.
Yeah.
Yeah.
Yeah, very much all of that. Yeah, it's yeah, like just because you have more of a single word, right, doesn't necessarily mean it's a more important word. There are plenty of words like that we use frequently that you might miss in a stock words list that really aren't as important as the uniqueness of some words, or so on and so forth. But yeah, it seems like y'all are understanding. So, so then what is it that that this is here, right? So, as I was saying, that this is a model that has kind of measured the differences in the vocabulary in a set of words, and part of the purpose to that is to be able to reliably replicate those patterns and be able to explain them. And so this will change here based on a number of factors, but let's see. So the ndim is the number of dimensions before the model says it can explain the word set, the variance in the word set. And so you can kind of see here that even though we have, what is it, like 132, yeah, we have 132 rows, and then I think of that, we have, maybe we're not there yet. But in any case, so yeah, we only need, what is it, like 60 dimension points of this kind of model before it feels like it can explain all the variation to the words that we've given it, that it kind of can have some predictability to it. So you can see here, if I cut this down to, what is it, like, let's just say 70. It's still, we're still explaining, though I'm a little, what's the word? I'm not sure about this. I wonder if this is correct. In the sense, first of all, I wonder if I did it right. Second of all, it just often is hard to get to 100. Like anything above 50, you're starting to get good. So the fact that it feels like it can get confident so quickly, maybe because it's a small set, but when I was running it previously, I ran it, I think, at using 33 tokens, and it felt like it could explain the whole model within 15 dimensions. And that seemed, I don't know, I don't believe that. But that's something to play around with for sure, to figure out but ultimately, yeah, proportion of variance. So that's kind of what I mean by measuring the space between the words, like the differences. That's the variance that I'm talking about there. Premise is the list, yeah. And so now we're going to talk about the dimension reduction. And that's the truncated SVD method. And I'm not going to be able to explain it like Fitz was able to explain it, obviously. But it performs a linear dimensionality reduction by means of truncated singular value decomposition, which I guess is the SVD. This is different than PCA. Does not center the data. All these fun things that I once knew and was tested on that I've long gone out of practice with, but the whole point is so that you can more easily represent the data spatially. Because how do you represent it? It's really abstract to talk about these parameters and the matrices as dimensions in the tens, sometimes the hundreds. Unless you can unless you've seen it, unless you've kind of practiced and it doesn't really make sense to most people. And most of the time, when you're trying to do analysis, the whole purpose of the data visualization is so that you can communicate what's happening in the data to people who might not otherwise be able to really properly understand it otherwise. But the point is that we have a model that looks like it can that it knows the data we've given it. That's the whole point of this, really, in the simplest of terms. And so now let's talk about the clustering, the k-means clustering, which is really cool. I really recommend y'all go out and try and test some stuff. Just find a set and mess around with it. It's really got a wide range of application, and it's unfortunate that they don't do more of that kind of stuff in the CS program, really. I suppose until you get into like the electives, but anyway. So you can see here, NT is kind of the number of clusters, and then let's see, this number here is just the number of rows we're going to have per cluster that show up. And so what this has kind of done is it's here, I mapped the data, feels like it can explain and anticipate the patterns of the data we've given it. And now we're saying, all right, now make some clusters. And so I don't remember the exact process, but it's basically you start with a point, and then you have a proximity of all these other points that have been represented, and it kind of just then maps those points to the cluster. And it does that a number of times until, actually it's a number of times to tell it to, really. But the point is that eventually you'll get these emerging groupings that can tell you things. So let's look at these two clusters here. We've got, let's see, taxpayer, accountant, supervisor, employee, employee, supervisor, engineer, client, and then the other one is customer. Can you guys see this? All right.
Yeah. Zoom in more. Perfect.
Asked to speak to the manager. Asked. Okay. So what I think I've seen what the algorithm picked up on. I think I see what it is grouped. Do you guys, y'all gonna hedge a guess at what the groupings are?
It's the employer and talking to the employee, or not the employer talking, but someone who's being paid talking to a client effectively.
Possibly. That might be one element to it, but we can see customer asked to speak with the manager, which is kind of a similar sort of, I suppose, payer-payee relationship. It's, to me, I think it's really simple. Don't overthink it. Just look, even at the first 3 lines. Taxpayer met with the accountant. Taxpayer. Supervisor gave the employee feedback. Informed. And then look at this. The customer asked. The customer asked. The student asked. So we have 2 groups.
Noun verb.
The what?
The noun verb.
Yeah, so this one, right. People are, there is a verb outside of asked. Cluster 2 is people are being asked. That's pretty much the cluster the 2 clusters we've got. And so let's see what happens when we double the number of clusters. All right. It's a bit long. Informed, surgeon operated. I don't know what the first one is. Can't say what the second one is. Yeah, it looks like it's really just, I suppose this is not the most overt example because a lot of them are so similar already. Also, it should be noted that what I'm doing here is there is the matrix representation that is then being used to kind of correlate to the list of phrases that I have. So this is not what's being shown here. You can see like you can see the to on all these simple words that we pulled out. But what I'm doing here, I've made this array using NumPy, and it's just kind of like per the cluster, to go ahead and print based on the fitted matrix, the k-means clustering. Because the k-means clustering has kind of been taught via our matrix, and that has now kind of looked back at the list we gave it and is now finding these patterns. And so advisor met with wanted. Yeah, I don't know. But anyway, this is just kind of a quick demo to show you guys like it's not hard. Like seriously, like just sit down, take a day, read the documentation, ask ChatGPT. It'll tell you like how to do it. And I don't just mean, that's great for doing for not doing your homework and all, but it's like what people really are undervaluing about it is that it takes these kind of sometimes what I would say poorly written, like documentation that's really clearly meant for someone who can already understand what's happening in this process, and make it more overtly explicit using plain language so that you can understand what you need to change, why it's doing what it's doing. It's really not, it's not as magic as it might sound. It's really just about practice and interest and following that. Yeah, I mean, does anybody have any questions in particular? I know I kind of flew through a whole bunch of stuff and I kind of just sprinkled in explanations, but really just to try and get the names out there and some techniques. On it, just the matrix representation, the cleaning up and pre-processing is just a basis for so much of what you're going to be doing. But yeah, anybody have anything, any questions? I can say what I did for the class was we scraped a bunch of actually it was free. We downloaded all these tax statements from nonprofits, and then we scraped all their descriptions, because they have to give descriptions of what they do from their tax documents, and then from that we basically identified nonprofits of interest based on their description using regular expression keywords, which is this spider language here. This actually identifies, this is kind of a longer, needlessly longer, complicated one for pulling out stuff from a comma separated value. But it's, you make the pattern, you identify sort of the format of the sort of the words that you're given. So it's part of the pre-processing, because the tax documents, it's not like they just give it to you to be able to start this clustering thing, and then yeah, from there we kind of went ahead and did a whole bunch of data visualization stuff with the given kind of our ability to identify these nonprofits. Yeah, and then I think in hindsight, as far as DataFest goes, my real problem is I was trying to graph a 50 dimension vector in a 2-dimension space, which is why it just took forever, among a whole bunch of other reasons. I wonder if I even have it. It might be interesting to just pull it apart later, but it was really, a lot of it's just duct tape and glue until you get it to work, and then you gain some understanding and you go back and you do it better, and that's that.
All right. So to finish off, we're good?
Yeah, that's what I got.
So to finish off the last few minutes of the meeting, Drew has proposed a fantastic game last week. You'll remember it in a second. So I have generated about 10 images from DALL-E 2, and we're going to guess what the prompt I gave DALL-E 2 given the image that was shown. I'm going to disconnect you real quick.
Yeah, that's fine. Just pull it out.
Yeah, just go to Discord if you're okay with showing whatever pops up first.
Do
you have Discord downloaded on there?
I do, but
Okay.
I'm just going to unplug it.
Yeah, go. And then go to my message. While Michael is loading that up,
I do have some quick announcements, if that's all right.
Go for it.
I think we're going to have a speaker, the Google Dev. Is it next week?
Next week.
And then campus is closed the week after that. And then the next 2 weeks, we're not really going to do too much, I don't think. I'm probably just going to try and get the expo paperwork sorted out, among other things. And we're going to hold elections. And so if you're interested in being an officer, that's your time to bring it up. And then Discord.
Yeah.
And then did you want to?
I'm good. This is going to be the end of my 2 years as an officer at the Data Science Club, and it's been quite a ride. Thank you. Yeah, it's insane that we're in November. We're like halfway through November, and we have tuition due in 3 days. So, if you are on a version of tuition where you pay monthly, make sure you get that in this week.
This here?
Any one of those, just pop it open and then plug back in.
All right.
All right, so this is our first. Please do not destroy my cable, Hashem. This is our first image.
Wait, can I have a sign-in slide?
Oh yeah, the sign-in slides. I put it in the Discord. Are you in the Discord?
Oh,
Yeah, I put it in the general chat, so go ahead and check it out
That's your
there.
wallpaper?
Nope, this is an image that was generated by ChatGPT. Sorry, not ChatGPT, by DALL-E 2.
Oh, yeah.
Given a prompt that I gave it. And
By
we're
the
going to
way-
guess what the prompt was to get this image.
Panda pins.
Panda canvas? Try again.
Panda chemist.
Panda chemist. Still no.
Panda making chemicals.
Air chemistry.
Air chemistry. Actually, now that I look at the prompt again, chemist is close. I'm gonna give it one more time. Sorry, what? Kung Fu chemistry. Actually, I'm actually kind of curious. What does Kung Fu chemistry generate to? Kung Fu chemistry. All right, we'll let that think. All right, so that prompt was a panda scientist doing chemistry in the style of digital art. I'm sorry, I'm looking at the Kung Fu chemistry that just came up. I'm not quite sure if I can show any of these.
I mean, they're not.
Not horrible, but
That one's a little.
they're a bit suspicious.
That one's a little. And that one too, I guess.
Yeah, we're gonna not show. All right, let's go to the next image. Hit
Call,
right or
call that a
left.
bias, I guess.
All right, so this one was kind of hard. The prompt didn't actually come out to anything close, or the image didn't come out anything close to what the prompt was. So, any guesses to what this prompt was?
Suicidal?
No, school is good.
Arizona University.
Close, but no.
Lizard school?
What's up, Mom?
People jumping off the Alamo.
People jumping out of the Alamo. That was fun. No, Hashem saying school was very close.
University of Lizard People? I don't.
That would be good.
This is a school with zombies for students in a utopia world. Like I said, the prompt did not even generate an image remotely close to what I asked for. So, it's a demonstration from previous where image generation is not always that great, and it's always fun to play with.
Cinnamon roll in the universe? I don't.
Honestly, now I think about it, it gave me 4 options. The other 4 options would have been a little more obvious.
How about, can we have like how many words the prompt has?
Okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 10.
Alright.
10 words.
I'm just gonna go with what if we get close to the general prompt. Just go for it, Mosh.
Doctor Strange spiraling around the multiverse
Doctor Strange
while seeing a shell that looks like Gary's.
Ooh, close. Very close. Alright, shell that looks like Gary is very close to the prompt.
Shell in the nest of light.
Close. Yeah, I'll give it one more try.
Something to do with spirals.
A disco ball made of spaghetti illuminating on a dance floor
Dang.
with a snail on top.
Oh.
I think it's close.
The Gary thing was close. Getting a snail was very close.
You see the snail.
Yeah.
That doesn't look like spaghetti. It looks
Yeah, it doesn't look like spaghetti on the projector.
Those
Up.
pictures of the snake where they like leave the they leave the lens open, I think.
Yeah, the high exposure images.
Exposure photos. Yeah, it looks like that.
If you look close at it, it does start to look more like spaghetti. But from frankly looking at the projector, it looks
Vaguely get a spaghetti thing, but it's.
it looks nothing close. No.
No. Oh my gosh.
All right. So, oops. Let me give me a
Next one?
second. Yep. Go to the next one. This
Oh.
one's a little easier.
An
like this
elephant
one.
on
This
an
one's cool.
elephant on a bike on cookies on popcorn.
Close.
Okay,
You're
now
very
Let's see,
Right,
I mean-
what?
closer. Go for it, Mosh.
The character from Cats riding Dumbo.
You have
spotted
gone
elephant.
so far off. All right, I think we can actually get this one without me giving any hints.
A man
outside
riding
of
an
your-
elephant on a bike on with a cookie
And a donut.
A destructive?
And a donut.
Close. I said I could probably not give an example, or a hint, but I guess a hint is necessary. It's more to do with what the floor is made out of.
Popcorn?
That does look like popcorn, but no, it is a squishy substance.
Marshmallows.
Marshmallow.
There you go. Try again. Let's see if we can get the prompt this time.
Elephant riding a cookie on a floor of marshmallows.
You are one word off. A polka dot elephant riding a unicycle through a field of marshmallows.
Ah.
That was very close, though. See, that one, it actually generated. I don't know what it was thinking with
I
the.
like this one. Out of all of them, I think this one's
Yeah.
my favorite. I could see this framed in an art.
Yeah, no. It also was the closest one out of all the ones I generated, although I'm not quite sure where this white being came from. It looks like a demented elephant.
Yeah, it looks like an elephant that's been hodgepodged into a human-like
Yeah.
shape.
It's really weird.
It looks
Regardless.
like a 5-year-old just learned Photoshop. It was given it.
No, this looks like someone who got their PhD in digital art and just burnt out and decided to make whatever monstrosity that is. All right, did I put another one? Oh, yeah, I did. All right, let's see if we can guess this one.
Some animals with top hats in the forest waiting for a tea party.
You were very close.
A Midsummer Night's Dream.
This would be a good alternative.
It's animals dressed as Abe Lincoln in the forest having a meeting.
I'm actually kind of curious if I just put Abe Lincoln hat if it would do that. But no, Mosh, you were actually one word off. A whimsical forest scene where talking animals are wearing top hats.
Dang.
Keyword I was looking for was whimsical, but in hindsight, you can't really. Yeah, you can't get whimsical out of an image. All right, did I have another one? Oh yeah, this one was just cute. This
Let's
is
see.
so hard, you'll never guess what the prompt was.
An Asian spaceman or Asian spaceman from the Martian helping a dog like in Robin Thicke's Blurred Lines.
Oh no. Oh my gosh, Mosh, you were so off. Not so off, but pretty off, Mosh.
It's shorter. It's shorter.
Is an emotional support animal
Shorter.
for astronauts?
That would be a good prompt for this image, but no. What about you, Alejandro? What do you think this could be?
Is it Leica?
Like
They
Oh, yeah.
goes into space.
Yeah.
And they-
what do
The
what-
Soviet dog.
Oh, the Soviet dogs? What do you think I told the image generator to generate? This is kind of fun. So we're basically just playing
Future.
no, we're basically playing what's that game where you give the answer and you give the question to an answer?
Jeopardy?
Jeopardy. We're basically playing image Jeopardy right now.
What is dog with astronaut?
Anyways, this one was photograph of an astronaut riding a dog.
Yeah.
Photograph vibes, because the white background looks like there's places that you go to in the mall to get your photo done, you know?
Yeah, it is. Like, there's just one
Yeah.
kiosk in the corner.
That-
Do a lot.
No, there's a straight
Oh.
up like photo like shop.
Yeah, yeah.
Right?
We don't really have a lot of those here in
Yeah,
Sacramento.
but it's become a trend recently to
Really?
remake doing family or friend photos to make them look like old cheesy 80s
I like
family
that.
photos.
I like
and
that.
it's like the most funny thing ever because you'll have like entire like siblings going and getting like these like look out in the distance photos.
Yeah, like the old, like the yellow ones, yeah.
The ones where they're like hold his left leg and
Like the really ridiculous one. Yeah,
Yeah.
in the Middle East, you'll find a lot of places like that. Like that's every family will have like an old timey, old style photo
Yeah.
like that. Here in California, though, it's I mean, yeah, obviously in some places coming vote, but it's a lot less. All right, this one's basically the exact same thing. Go for it, Mosh. Let's hear what you can come up with.
Let's see. Astronaut traveling on a horse, flying in space, traveling every planet possible.
That's a very descriptive prompt for a very for a very simple image. I'm going to give you this. My prompt was a lot shorter, though that would probably get you a much descriptive image.
Yeah.
This one's just a simple astronaut on a horse, but I think, ooh, actually, this one's fun.
fox.
A fox out at night, gazing
Close.
at the stars.
Closer.
Of a fox.
Closer.
A
You guys have all the right words,
Oil
but
painting of a fox in the Starry Night.
there you go. Painting of a fox in the style of Starry Night.
Oh, there you go.
Yeah, I think that actually is the last one. Yeah, it's the last
Yep.
one.
Back to the panda chemist.
Yeah. Hindsight probably could have executed that a bit more interactively, but
By the
We're
way,
disconnected.
how do you
Go for
feel
it.
now that Microsoft banned their employees from using OpenAI's ChatGPT?
I think it's a bit cyclical, or I'm using the word cyclical incorrectly. I think it's a bit ironic that the company that effectively made ChatGPT has banned it in its own company.
Wow.
But
I think it's most probably because of how laws are going to be surrounding it, that it might cause
issue. I think the bigger issue is that they know that ChatGPT is not that great, and they don't want their engineers coding with ChatGPT, which is more likely what's going on. Either way, that's all I had for today. We have a lot of pizza left and a lot of sandwiches. So,
It's like a lot of food this time around for like no reason.
I mean, I ordered a lot of food, and Victoria graciously brought a lot of food with her for the meeting. I do thank you for that, and we just ended up with a lot of food today.
and not many people came. Usually we have
I mean, we had a few people come in and leave, but you know,
Are you guys in finals still or in midterms?
no, we should get a lot of midterms.
I have a midterm next week. Midterm 2. The electric
Yeah.
boogaloo. But yeah, it'll be fun. Either way, look to your left, look to your right. Say hello to someone you haven't talked to before. That, and if everyone.
Do we have a room for the speaker yet?
Oh, yes, actually, let me grab the.
We're not going to be meeting here next week.
Next week we don't have the room because who knows why the union's very good at what it does. Next week we are going to be.
Well, we
I'll have
we,
to follow up.
Yeah, we can send it out as an announcement, but just so y'all already know, next week for the Google Dev speaker, we're going to be in a different room, not this room.
Wait a sec. Is that the same Google Dev speaker from the
Yes.
alumni night?
Yes.
Yeah, the one we were together?
Yes.
Okay, cool. If everyone's cool with it, something we used to do is that we used to wave at the camera to close out the live streams. So if everyone is cool with getting up here towards the middle and waving at the camera with me,
Which camera?
back one.
Back one.
This one back there?
Yes.
Is that your camera?
The one that's in front? Yes.
No, the one in the back.
The one in the back is the one that's been here. Hold on. So the camera is looking this way. So everyone over here behind this table. Hey, Drew, come up here.
All right.
And Manny. And you just told me your name 30 minutes ago, and I should really know. Sarah.
What are we doing?
We're waving at the camera. Like
They wanna
we did
wave
last
at the
semester.
camera?
Yeah, come on, guys. Come on up.
Yes, Manny, you can do it. All right. Camera's back there.
Huh?
Bye-bye,
Bye-bye. Bye-bye.
All right, cool. We're good.
Also, take food, please.
Yes.
Everybody, take more food.
All right, cool.
So is it?